Welcome back for another video here at Math Rocks with Mr. Cox. Today's video is all about triangles. And you can see three different triangles over here, and you might be wondering, what are these little symbols on them, these little marks, either on the sides or on the angles? Well, this video is going to explain what that means, and also what does it mean for a triangle to be congruent to another triangle, and how do you prove that one triangle is actually congruent with another? So with no further ado, let's get it on! So what is triangle congruence? What does it mean when one triangle is actually congruent to another? So down here you have two different triangles here. One of them is triangle ABC and another one would be DEF, for instance. And for one triangle to be congruent to another, it has to be true that all three corresponding sides are congruent and all three corresponding angles are congruent as well. And that's kind of a mouthful here, so let's take a look at each triangle here and see how that works. So you can see here on angle C, it has one mark on it, and same thing over here on angle D. That means angle C and angle D are congruent. Angle A and angle F have two marks on them, and angle B and angle E have three marks. So it means angle B and E would be considered corresponding angles, and they are congruent to each other. Same thing for the sides. Side AC, for instance, right here has one mark on it, and so does FD. You can see that DE would correspond with CB because they both have two marks on there and they are congruent to each other. And same thing for EF and AB. So with that being said, you can write triangle congruent statements. So I have down here triangle CAB is congruent, and by the way, that's how you say congruent instead of writing out the word. You have an equal sign, a little squiggly mark above it. And if I say CAB, I have to say triangle DFE, and here's why. C, that angle has one tick mark on it, and you'll notice up here that the other triangle that has one tick mark, this angle would be angle D. So if C comes first, D must come first over here. Then I said A has two tick marks on it, and F has two as well. So then I have to say DF as would be my second letter, and then E would be what's left over. So I must, if I say CAB, I must say DFE over here. Well, it turns out that you actually have 5 different shortcuts to proving that triangles are congruent, and you don't need to prove that all three corresponding sides and all three corresponding angles are congruent. So what are those shortcuts? The first one is referred to as side, 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 or SSS congruency, and that's where all you know is the three sides are congruent to the three sides over here. The second shortcut would be what's called side angle side, or SAS, and that would be two sides are congruent to two sides, and the angle in between them would be congruent as well. And that's why we have side angle side, because the angle is in between the two sides. The third shortcut is called angle side angle, and that's where we have two angles with the side in between them being congruent to the other. And then the fourth is similar but a little bit different. Yes, we have two angles, but you'll notice here it says angle, angle, side. And what that means is, yes, we have two angles that are congruent to two angles over here, but the side is not between the two angles. And then finally, our last one is called hypotenuse leg. And for us to use the word hypotenuse, we have to have a right triangle. So that's why you see the right triangles here. And then one leg and the hypotenuse have to be congruent as well. So those are your 5 shortcuts to proving that triangles are congruent. If you like what you've seen and heard so far, please like, comment, or subscribe. Thank you, and back to part 2. Let's take a look now at how we prove that two triangles are congruent to each other. There's a couple of ways that we'll use during the course on how to show that they're congruent. One is what we call a flowchart, which we're going to be using today, and later you'll learn how to do something in what's called a two-column proof. So let's talk about how to do a flowchart. If you look over here at our figure, we have a triangle on the left, triangle on the right. There's some information given to us. For instance, we know that RA, that line segment, is actually congruent to line segment AV. So I'm going to go ahead and write that in here. How do I know that, by the way? It's because I could read. So I'm going to say given Then the other one would be angle B. So we have angle B is actually congruent to angle E. And once again, that was given to us from reading the diagram. So we have two different conditions here to prove that these triangles are congruent. However, we need a third. So if you recall back, when two lines cross like they are here, it creates what we call vertical angles. So we have a vertical angle here on the left and one on the right. And when we have these vertical angles, they are congruent. So I'm going to go ahead and put two little tick marks here. So I'm going to say involve angle A in my description down here, but I can't just say A because I'm not really sure which angle that might be. There's a lot of angle A's over here, so I have to use three letters. So I'm going to say RAB. So here's my angle RAB. And then I'm going to say congruent to angle, I would say EAV. And once again, how do I know that? We got to write it down here. So we are going to say vertical angles, and then we can say right after angles, congruent. So vertical angles are congruent. So now we're ready. So I'm going to go ahead and I'm going to name the triangle on the left. I can say anything I want as long as I just say them here in order. So I'm going to say bar. So B-A-R. Now once I say that though, there's only one correct answer for my second one. So I'm looking at angle B. The angle that corresponds with that would be E. So I'm going to say that first over here. I'm looking at angle A. So I'm going to go down to angle A, which is right over here. So I'm going to say A, and that leaves the V last. And of the five conditions, which one is it? Well, I've got two angles and I've got a side. The side is not between them. It is actually across from one of them. So this is going to be what we call angle-side congruence. All right, so here's another set of triangles here, and we are going to prove that they are congruent. We're given some information in the diagram, and also we're given some information over here. So let's start over here in the actual directions. So we are going to say TS, that line segment, is congruent to line segment ES. How do we know that? Because that was given to us. Secondly, we have this angle S over here, and we can't use one letter because we don't know what angle S that might be. So I'm going to say TSB for one of them, so angle TSB, and my other angle would therefore be ESB, so angle ESB. How do I know that? Because it was given to me. Also, I'm going to go ahead and mark my diagram for TS, so here's TS being congruent to ES, which is going to be over here. Now, once again, we're a little stuck here because at this point we only have two different statements here to prove triangle congruence, and we need a third. So the last thing we can do here is they share this side right here. So that means that because they share a side, that we can use that now. So I'm going to say line segment BS is congruent to line segment SB. And that, when we share a side, we call that the reflexive property. So I'm going to go ahead and write out reflexive property right over here. And I'm just going to write PROP instead of out the whole word there. And finally, we're going to come up with our statement. So let's go ahead. I'm going to name the one on the bottom. So I'm going to say triangle SEB. And as always, once I say one of my triangles, the other one has to be said a certain way. So I'm starting here at S, which is where my one mark is, and I went along the side that had the one tick mark. So I'm going to start at S and then go to T on the top one. So I'm going to say S and T, and that leaves B left over. And this time I've got two sides with the angle in between them, so this would be called SAS, and then congruence. So now you know how to show that two triangles are congruent.